Hello. Today we're going to be studying exponential notation. You've probably remembered the word exponents from learning PEMDAS last year in 5th grade. So we're going to take it one step further this year, calling it exponential notation. Exponential notation, time out. Always take notes, right? So go and get your notebook out, pause when you need to, but definitely need to take notes. Exponential notation is repeated multiplication. Repeated multiplication. The base is the number being multiplied repeatedly, and the exponent tells you how many times to write down the base as the factor. So exponential notation, base, and exponent. So get those words copied down and the definitions, and we can talk further in 1 second. So this is an example of exponential notation. 3 is your exponent. So 3 is the exponent. 2 is the base. So we write down the number 2, because that's the base. And then this tells me to write down that number 2 3 times. As you can see, I didn't say 2 times 3. I said I'm multiplying the base of 2 3 times itself. So 2 times 2 times 2. So very important. Once you get your head around that, it'll make a lot more sense for you. But this is the base, and that's the exponent. So going back to the last slide, remember that the base tells you that's the number being repeated, and the exponent tells you how many times to repeat the base. So the base, the repeated. So let's do another example. We have 2 to the 3rd power, or 2 cubed. So this looks like 2, again, 3 times itself. And then the way you solve that is you say 2 times 2 is 4. Bring the rest of the problem down for the purposes of, practicing. And then 4 times 2 is 8. So 2 to the 3rd power equals 8. Let's do another one. 4 to the 3rd power, or 4 cubed. It's the same as saying 4 3 times itself. So 4 3 times itself. So 4 times 4 is 16. Bring down the rest of the problem, and here's where I'm going to have to do some scratch work because I don't know 16 times 4 in my head. And I find out that 16 times 4 is 64. So 4 to the 3rd power equals 64. Let's do one more. 5 to the 2nd power, or 5 squared, is 5 times itself, so twice. 5 times itself twice. And then 5 times 5 is 25. So 5 squared is 25. All right, a couple of more definitions and then we'll be good for today. 4 to the 5th power, so this is 4 to the 5th power, can be read, as 4 to the 5th power. 8 with a 6 can be read as 8 to the 6th power. If it was 8 and a 7, it would be 8 to the 7th power. So you call it whatever that exponent is. The base to the exponent power. Our last two notes, 7 to the 2nd power, can be read as 7 to the 2nd power or 7 squared. So you just know that whenever you hear either of those two, 7 to the 2nd power or squared, that means that the base is to the exponent of 2. Okay, so that exponent of 2. So any exponent of 2 means squared. And then same with a 3. Not the same 3. With the 3, you can say 5 to the 3rd or cubed. Because that's, the 3 dimensions is the 3rd. And any exponent of 3 means cubed. So I hope that helps clear up what exponential notation is, so that when we're getting ready to go into order of operations, and you see, for example, and you don't have to record this, it's just for your knowledge, you know how to go about solving 3 to the second power times 6, and then go ahead on with other parts of ordered operations. But the exponent is one of the early steps of PEMDAS, or ordered operations.